So let's hit all the basics of the y equals ax squared plus c form. We can sort of compare this to what we know about y equals mx plus b. The biggest difference is that we have an x squared term. That means this equation is of degree 2. We call anything of degree 1 linear, and all the graphs are lines. We call anything of degree 2 quadratic. And the shape the graphs make are parabolas. The b was our y-intercept, and it was our constant term. We now use c as our constant, and it is also our y-intercept. Before, the coefficient of the x term was the slope. But the slope of a parabola is always changing, so a is not the slope. It is something sort of like slope, though. One thing that a does is it gives you smiley or frowny parabolas. A positive a will give you a smiley parabola, but a negative a will flip it over and give you a frowny face parabola. Another thing that a does is determine how sharp or wide your parabola is. The bigger the a, the sharper your parabola becomes. The closer to 0 a gets, the wider your parabola will be. Now we're going to look at a few important points on a parabola. Where the parabola crosses the y-axis, we get our y-intercept. Where the parabola crosses your x-axis, which is oftentimes in 2 different spots, we get something called our roots. The x-intercepts are called roots on quadratic equations. The last really important point is at the very top or the very bottom of the parabola. This point is called the vertex. One more thing we should see is this special line that goes up and down the middle of the parabola. We call it the axis of symmetry because if you folded the parabola over it, it would be exactly the same on both sides. I think that covers the basics, but I'll make a few more quick points. One is that PEMDAS tells us that exponents need to be calculated before multiplication. So if you're plugging in numbers to y equals 3x squared, you must square your x before you times it by 3. 0 times 0 is 0, times 3 is 0, 1 times 1 is 1, times 3 is 3, and 2 times 2 is 4, times 3 is 12. And the last point is that you can graph any quadratic function just by plugging in x's and finding your y's, and then using the coordinate points.